Okay, welcome everybody to this presentation. It's the first one of two that we will have regarding how to use some of the cloud services that that will be a crucial thing for this Hack9. This one is presented by myself and Anna Maria. Hi, Anna Maria.
Hello guys, I'm Anna.
So this one is enhancing the power of AWS Cloud Solutions for a worldwide workload. This presentation will consist of three different parts. Okay. The first one, and maybe the crucial one to understand the data a little bit, is going to be data characteristics, which are related to how to determine and what to track on the data itself. Then it will be consist of data manipulation, where we will present a little bit some of the, not the problems, but some of the situations that you can be involved and what you can use or what you can refer on AWS. And the third one, which will be presented by Anna Maria, it will be one example how to use these combined services. So let us start with the data characteristics. I don't know, but did you heard or not? But there is a 6 V's now. It used to be 5 V's. The latest one is variability, which was introduced in the latest years. So the parts of the data which you should make note or interest are the volume, velocity, variety, veracity, value, and variability. In a sense, the volume itself is just a size, and what you can check is the size or the size that you will want to transform or extract or whatever. Regarding speed or velocity, it means that speed of data generation, how you can or how is time consuming to generate the data itself. Variety in a sense, it's ways of how data can be structured, semi-structured or non-structured. It means the type of the data. That will be a little bit covered later. Veracity, in a sense, you have to trust in your data, and you have to make sure the quality, integrity, credibility, and accuracy of data. The value is always something that is intriguing. Why? Because you need to have a sense what the data means to you. What is the value and what is the problem that you have. Variability, it's why is that the crucial thing in nowadays is because variability, it means that how data or how the data sources are being changed. In the big systems, that means that sometimes you integrate with the data using API. The second thought, when you switch to some of the pipelines, the data can be changed. The data that you receive will be just a partition or not partition, etc. In that sense, that is a crucial thing when you emphasize or when you're creating the architecture or the solution around it. So if you go deeper, I will use some of the slides one slide from the one of the previous presentations because it will give you a sense what is the increasing size of the data from 2010 to 2025, which is they believe it's going to be 175 zettabytes. Probably will probably a little more. For now, we are in the stage that it's around 80 zettabytes, but still I believe it's more. So it means that if you want, if one man wants to cover all the data itself to see what the data is, it will take him like 2 million years. So that means that no one man can know all the data. The second thing, which means the speed of data generation.
So if you are changing some slides, just to know that nothing is changing for us.
Sorry.
Okay, so now it does.
Yeah, sorry. I was speaking but not clicking. Sorry about that, guys. So this is an increasing size that I thought that I covered. So you see on 2010 it was really low in zettabytes, but 2025 it's increasing around 175 zettabytes. And you can, on the right side you can see what is the verbiage on after the terabyte, petabytes, exabytes, zettabytes. So you see it's huge. Okay, I believe now when I speaking about speed of data, we can speak on 4 different stages how we deal with the data. I'm speaking now not of the data itself, but the big data problems. So we can ingest data, or we can interact with data in batches. Those batches can be scheduled. That means that can be periodic then. Near real time means that it's neural streaming, or it's a sense of streaming, but it's not in every second. And real time, which means that every second or every minute is covered by the data itself. Once you have these 4 and you have the problem that you want to resolve, then you have to take in a sense which architecture you're going to use. So you not use the same architecture or same services or the same tooling to deal on these 4. So that's why it's crucial to understand which problem are you trying to resolve. Okay, now we can say how that is being changed. That means that sometimes it's the size of data. It means that you can expecting like I don't know, gigabytes, and after that you have hundreds of gigabytes, which will affect you and your performances. The type of data also can be changed. Sometimes you can interact with a JSON and they switch to XML or some other data type. Source of data also, as I explained, also it can be API, then can be switched to pipeline or some other service. And the time of retrieving data is also something which it can be in a sense to also make like, let's say, a different approach as you used to have. That's why you have to always check what is the time that you will get response of that data, or the time you can get data at all. That can be also, in a sense, when you're integrating with the third party or some of the clients, it means that when they will finish their part also. So this is not only a time of when the system is active, it's also when you are sketching it or when you're preparing it and delivering. Okay, data manipulation. Now on this subject, probably the first thing that it's pop up is the storage. We distinguish a couple of things in the data storages. Relation database, which are more traditional database, are the database where you store a lot of amount of data, but still it has some boundaries, especially when you do some reporting and you have several millions of records that even if you have indexes, that database will be slower and slower. We distinguish 2 types of relational database. One is a row-based, and the second ones are column-based. The column-based are the databases which are dealing with a huge amount of data, and it's good to have for reporting purposes. Now, when we are saying NoSQL, it means that there are the type of data which are not structured. So in there we have a key value, document, graph, or white column store, which can help us in either way what we are storing the data for. So once you have a problem that you have, or once you have some architecture that you want to emphasize, then you have to think about which NoSQL we'll use. It's not every NoSQL is perfect for every situation. That depends on the things that you want to create. After this, as I say, relational or non-relational databases, we have a warehouse. The warehouse is different from the column-based relational database because it's a little bit structure that we create to create a value for a customer, and also we want to create a model which will serve a lot of different stakeholders and a lot of different variety of users, because we want to have as much as speed, as much as fast data as we can. And last but not least, the data lake is an answer for a lot of problems that impact during the years of dealing with the data. Data lake is a place when you store different types of data. It means that you can set structure, unstructured, and semi-structured in the same place, and you can query on top of that. Having that in mind, that enable a lot of other things what we can do, and also on top of that, the data science and creating a warehouse and doing a lot of things is now enabled, which is a good place to be in a huge project. If you have some questions, please interrupt me, or you can wait for the end of the presentation, or even my part. So just I encourage you, so if you have some questions, please ask. Don't wait to wait. So in the sense of storage on AWS, we have a couple of services which are interacting with the sense that I explained in the previous slide. So we have RDS service, which supports multiple type of database. And also you have Aurora, which is full managed service. It will scale for you, and it also will give you not to deal with the properties or different configurations on RDS. As we can maybe say, RDS service is maybe for the guys or the companies which want to full manage the storages, but the Aurora is somebody for who is not so into it or not wants to be bothered with that. All is in a different sense the way that you want to deal with the problem that you have. Also, you can use both of them. It's totally fine. Now, NoSQL services, we have also as a key value, we have DynamoDB and a key space. Also, you can see DynamoDBs can be used in document, and for graph database, it's Neptune. I put time series as a time stream because I believe that guys the day before explained how they create some solution. So this is also thing that can help you probably for IoT to create a time series database which will have all necessary data. When we are speaking about warehouse, we have a Redshift, which is a huge instance or a huge beast to deal with. It's not something that you can assess or you can create a configuration in one day. You have to think about what you are dealing with and how to partition the data and how to use that in a Redshift as a service. On S3, using serverless, it's a little bit less complicated, and you just create the partitions in S3, and you a little bit also prepare yourself for a warehouse that you want to utilize. As also data lake. Data lake is just an S3 object. What we think, and a lot of people around the AWS think that Hadoop is under the hood, but that's that's something which is not fully and transparently communicated to others. So this is just a consumption. So assumption. So data lake and S3 is the way that you create a hierarchy on the S3. So when the data comes, you want to create a raw data place where the all raw data lies. Once you deal with the ETL process, then you will create different stages of an S3, and then you will create all partitions, which means that you will utilize data furthermore in the sense that you want. On the right side, I just put some of the icons that you will be familiar when you saw that on your accounts. Okay, now the second thing that once we have a data, we need to do something with that data. So we have an ETL process, which means that we will extract, transform, and load data to somewhere. So some of the things that we do with the data is clean data. So if you have null values, or if you have some bad data, or you have some things which will break your model, you have to reorganize or clean the data. We can change the type of the data. Majority of the once we want to utilize data lakes or the other stuff on S3, we change to parquet type. It's more like the type file, which is more used to create processes around it, and also to query the data. Also, the thing that we should also have in mind is reduce size, because we don't want to keep as much as data in later stages of creating a data lake or warehouse. Hash data, it means that if we have some GDPR or CCPA compliant, we need to hide some of the personal data. In that sense, we have to think about the hashing the data. At last one step, as ETL is stored to desired step or location, it means that either you're gonna put the data to another step if you're creating a step function or some other process, or you will store it on some location if the data prepared to be in that particular stage. So having that, and also merging also having that and in the AWS sense, so how we use and which services we use for a different part of jobs. Lambda, our AWS Lambda, I believe everybody heard about that. We use that for smaller tasks, in sense that we can do, because the Lambdas are like 15-minute jobs, and it's only lasts for 15 minutes, then it stops. We can use that for a smaller chunks if we are using, or we can use that for smaller parts, or even when we want to write to some relational database, if you have some monitoring or if you have some batching or whatever. For the bigger tasks, if you have a thing that you want to run a little bit of, as we can call it, Spark queries, the best way is for utilize is a glue job. The glue job is a job which is an AWS specific, and you just have to configure what that glue job needs to be done. Also, in a sense, you can configure it with the manually, or you can create by a code, which means that you can create dynamically Spark queries, which then you can run on the glue jobs. EMR, we can call it, somebody call it in a sense, it's Lambda on steroid. Because on EMR, you don't have that time difference, but you have to think about configurations, which means that you need to think about memory process, and you have to need to think about which instance type you're going to use for the task that you have. So it can happen that for a small task, if you don't think in the front, you can spend a lot of money, which is not the way you should utilize AWS. Step functions, it will help you to create orchestration. In those step functions, you just define steps. Some of the steps can be Lambda, Glue, EMR. You can combine everything and just help you to orchestrate what you need to have, how to deal with if you have error, not error, and etc. You can visualize, and also you can create corresponding steps regarding what the problem you want to resolve. Each two instances. So that means that if really it's a part when you want to do some bigger change, that's something that maybe when you want to hash the parts of the tables, and you need to use some of the different languages. It can be Java, .NET, whatever you like, and that can be created as a separate service, and it can be involved in some of the steps, and then you can use also then each instances to help yourself to create or to orchestrate what you want to deal with. As you see, it's variety of service. You don't need to use everyone. You just focus to create a set of things that will help you in the problem that you want to resolve. Then after the ETL process, that means that we need to store data somewhere. In a way, we distinguish in architecture principles. We can deal with data on request, on event, in batches, or streaming, depending on also how you would design the architecture around the problem that you want to solve. In that sense, storing possibilities on AWS are huge. I put maybe the 4 things that are correlating in the slide before. So if you want to store some database or write some files, as I explained, you can do it on Lambda, but also you can do on all other things, services that I explained. You can also create some EC2 instance, or even you can do it in EMR, which is not for that, but still you can use that if you want to have only one place. If you want to, or want to integrate data with somewhere, you can use SQS or SNS, which can help you coupling steps or writing to any other parties or EC2 instance if you want. SQS is a queue, persisting queue. SNS is not. So if you want to have a message where you want to send and you want to all subscribers only once read, then you will use SNS because you don't need to preserve that. But if you need to make sure that every message is deal with, and also you want to have a possibility to the retry mechanism, if that's not if that's some error pop up, then you should and you have to use the SQS. So if you dealing with the batches, as I explained in previous speak about what the tools we can use, for sure there is a EMR jobs running Spark queries, and also one of the things what we are using for delete a lot is S3 batch service, where you can define what needs to be done in batches, and then the AWS will run those for you. Last but not least is the streaming data. Kinesis is used for that. Is also used for event purposes. Okay. Analytics. After you store the data, extract the data, transform the data, and store it to other places, data is ready for consumption. So that means that you can also use a BI around it, some machine learning or some AI. Really, those are the 3 outputs of analytics. But in a sense of the AWS, it's more robust. Yeah, data delivery. So maybe yeah, I skipped this one. Sorry. Analytics tools on AWS. So QuickSight is for data enablement, is the fastest way to create a dashboard or something to create a visualization of the data that you want to use. Machine learning, for machine learning, SageMaker and Amazon machine learning are the services that you can use to run your models on some different algorithms that you want to check. For SageMaker, there's a lot of algorithms, and all of those are created for the persons who are not data scientists to try it and to see if that fits for them. Maybe they will have a sense, or they will have some value, even if they are not data scientists. For artificial intelligence, SageMaker and Amazon Forecast are probably the ones that you will use. So if you see on the slide from left to the right, the left one is the QuickSight, the SageMaker, Amazon Machine Learning, and the last one is Amazon Forecast, the green one. So these are the icons that you can try to find if you want to use this service. The last thing is data delivery. Data delivery means that you will deliver some output, and also the reporting. It means that you will report on some of the KPIs or whatever the company or who want to deal with the data will utilize. Distribution and consumption. Distribution means that you will propagate data to other pipelines or to other services, and consumption is that some of the AI or some machine learning will consume the data itself. I already take a lot of time, so I will maybe not speed up, but yeah. If you see this picture, this is a huge picture that probably cover a lot of services that you can imagine on AWS. So if you see the top, it's collect, store, process, analyze, and then consume the data. I will take a little bit more time to just try to give some data flow diagram, just to see also how can be this draft. So you have a source generation, then you have ingestion layer, storage processing, value layer, which means that the value is something that your model needs to be created, and then target consumption at the end, where you want to how do you want to use the data. You can see all these three boxes inside are essentially part of the ETL process, as I explained to you in verbally, but this is how you can see in the graphical design. A last thing that I want to cover is Lakehouse architecture. It's very popular in a sense. What we are creating for our clients, a lot of things we are creating this same thing. So we start with the source of data. We get a lot of things that can be public APIs. It can be some of the data which is on some sensors, some data which is in their databases or whatever. So we have to ingest that data using pipelines that we integrate with. So we want to put, as you see in the data lake, this is an Amazon S3 data lake that I explained to you. And the first box, as you see, is the raw data. Always we storing the raw data, and then after that we transform, and it enables us to retransform or re-process the data every time that client change their mind. You see the transformation. It can be utilized with a different variety of services, as I explained to you. You can see that on an image. Also, a value layer also means that one of the services that I didn't mention is Amazon Athena. It's really sweet service because you can query data even they are not structured well. That means that you can query data even in raw phase. Just use glue. You configure glue, and that will create a Athena table for you. And also visualization to end user. It can be a variety of things. These user links that I create for you is the things that you can a little bit investigate for yourself, and also you can start learning about that. Okay, Anna Maria, that's for me. I believe you can now take over. Sorry, guys, if this was boring, but I tried to be as much as interesting as I can be.
It's fine. Let me try to share my screen. So now I share this, and from current slide. Yeah, can you see it, Kosta? You at least?
Yep. Yeah.
Okay, so Amana, I will start presenting to you a little bit of an example of how you can combine some AWS services in order to solve a problem based on the type of data that you have, and it's somehow related to Hack9. So let's start. Basically, what do we know? We know that we have some data stored somewhere in the cloud. What can I do with it? So I can pre-process it, I can analyze it, and I can apply some cool data science stuff. And then the question is, so what do I do with the results? I can store it in the cloud. I can maybe send it further to, as Kosta said, QuickSight and do some dashboards and I don't know, cool stuff in the cloud. Yeah. So the purpose is to explore as much as possible the services related to the data that we have. There are some AWS services that can be used in data science. As Kosta mentioned, you have SageMaker, which is a really cool tool that allows you to, for example, use AWS Marketplace to call some pre-trained models of machine learning. You can go for Amazon Forecast and DeepAR. For example, this is used for time series. We will also look today a bit more into S3, which is used for storage of data. There is AWS Lambda, mainly used to trigger an action. EC2, which is namely virtual machines that you decide exactly how do you want them to function. There's a quite long list from which to choose. And it's worth mentioning Glue as well, which is a really cool ETL that AWS provides. So the use case we are going to look into today is, I know I have some data stored in the cloud and I want to do the following. While I upload the file on S3, which we know is serverless storage, I want to call a Lambda function that does something with that input that I gave. Either call a data science service, either do something locally with keeping in mind the 15 minutes running time constraint. Then I want to grab the result and write the result somewhere. And mainly, in general, it is used Python, but we will see later on there's plenty of choices. Both me and Kosta mentioned serverless. For those who are not aware, serverless is are some services that are provided by these cloud providers like AWS and Azure. And what they mean is that I don't have to care about scalability. What I pay for is the invocations, so I don't have to think about servers and provisioning and computer and memory and all those stuff. They basically just do it. And this is an example that can be considered for our Hack9, meaning that you can have this part. For example, I upload a file on my storage serverless service. I trigger some behavior and I store the result, or when I trigger the behavior, I pre-train or use the data that I have access to, for example, train a machine learning model. I grab the results, I send it to Lambda, and then I store it, or I send it further to QuickSight to do a dashboard, or you can even save it in, let's say, locally and download it. This is just a use case that you can consider for the Hack9, but it's not, let's say, mandatory. It's just, yeah, play with it and explore as much as possible. So we mentioned multiple times Lambda functions. So what is a Lambda function? Lambda function is a serverless service. It's a virtual function, and serverless, yes, also means that scaling is automated. So this is like what it looks like in the management console. Basically, I know I have a Lambda function, and this Lambda function gets triggered by my behavior. This is how I configure it, by uploading a file. So I know that in my S3 bucket, when I upload a file, I trigger some kind of behavior and I do something with the result. As I mentioned, it's scalable. there is pricing per request and computing time. You can play also, if you're curious, in your free time. Free trial in Lambda is very generous. I think you have like few millions invocations that are for free. As I mentioned, it's trigger event driven, it's reactive. And when you create a Lambda function, you can choose from multiple programming languages. So you're not stuck with Python, to put it this way. You can use C#, I don't know, Java, or other programming languages. S3, it's a cool serverless service as well. It's a storage place. You design your own buckets. Sometimes your buckets and the content of your buckets can look like folders with files, but S3 never sees folders and files. What it sees is prefixes. So it's like objects rather with objects, and you manipulate those objects. You don't have the concept of a file and a folder. So if I have for example, in my S3, I create my own bucket, and then I create an object which is called my folder, and then I upload my own picture. Those are objects, both my folder and my picture. You can also host a website on your S3, like you upload your index.html, and if you want an error HTML, and you can make your website visible by uploading those files. Do's and don'ts. The funny part about S3 is that when you use it as a triggering for your event, it's not necessarily recommended that you write the result in the same bucket where you actually upload your file, because you might end up with an infinite loop. What you should do is to create different buckets, the one for the input and the one for the output. Give it a comprehensive name. When you create your own bucket, do not be surprised if Amazon says there's another bucket globally that has the same name. So just try to add more keywords or stuff like that. Do block all public access upon creation. This means you protect your own bucket by attacks and data leaks. Assign proper policies per bucket. You can design what exactly you want to be able to do with the bucket. For example, I want to restrict my bucket to only uploading files to it, or maybe just downloading files from it and not both, or there are plenty of actions that you can design. And yeah. And the prefix part, the folder looking part, is mainly used, for example, if I have a behavior that I want to use on some of my files, on some of those objects, but not on others. So basically you use the naming to say, okay, you can upload here and please download from here, and stuff like that. This is a very basic example of how your code is expected to look like in your Lambda handler. This is Python code. So yes, your Lambda function has a little bit of code. This is a basic example where I have my Lambda handler, where I just call a method. I think the name of that, yeah, is write to S3. Mainly what do I do is like I grab my file, I print like that my new object was uploaded, so I can grab the name of the file object and the key of the object. Then I do a little transformation. This is a dummy example where I just make a string from my array. And then I give the output bucket name where I want to write my result. Okay. CloudWatch is another serverless service, which is pretty awesome, and it is mainly used because you can print and console log many things from your Lambda function. And once your Lambda function gets triggered by uploading an event, or maybe you want other kind of behavior, it's really cool because it monitors, and you can use it for monitoring, but it shows you all the small events that take place when your Lambda function gets triggered. And it's also the one with the error, because many things can go not as expected when we are dealing with cloud. And when you go to CloudWatch, you can actually print out the errors and see maybe I don't have the proper rights to upload to that bucket or download from that bucket, or I don't know, many other things that can happen. And this is like a list. If this list is endless, it means you might have an infinite loop. So do go and remove the behavior. For example, I started a request ID, and then I make some printouts, and then I get the end. And you see this every time you log, you trigger your Lambda function through the behavior of uploading a file on S3. Yes, these pieces of line of code were heaven for me, because there were things that were not working properly when I was starting with AWS, and just by returning the error and not just printing it, you can actually catch and see where do things don't go as expected. So yeah, and then the IAM, as I mentioned, is the one with the roles. Basically, your every cloud object and function and service, you can have some policies. For example, on my S3, on my output, AWS certification bucket output, I have the right to put objects and to get objects. And you can edit the JSON by removing policies or by adding policies, depending on what you think you need at that moment. Okay, what is another service that is worth mentioning is Amazon Forecast. You can use it to train your own time series. You can use it to import your data, you can train a predictor, and you can generate some forecasts that you can furtherly send to another service or download them. I don't know, in a file, or put the results on S3. It depends on what you like. And the cool thing about Amazon Forecast is that you can call different methods. So if you're familiar with time series, you can choose between Sarimax and Arima and even Prophet. And Prophet is, for example, a library for time series that is designed by Facebook. And it's really cool because you can also make it work with non-daily data. So for example, if I have 6 months of data, I won't be able to grab some yearly pattern because I don't have years of data, I have months of data. But if it's collected every few hours, then I get to work with non-daily data, and I can actually make some cool predictions and see what is the trend that I'm looking at and what is the behavior. Okay, so the steps to use Amazon Forecast, and I also gave some reference to some notebooks where there's Python implementation of these examples. You import the data, so you have to prepare it in some way. You define the schema. For example, I have multiple columns in my data set. Which ones do I want to consider as predictors? Then you train, you choose a model. You can also go with some default examples, and yeah, you can generate cool forecasts to obtain some predictions based on seen data. Visualize and compare results. And also Glue is another serverless service. You can use it to organize, clean, validate, format your data for storage in a data warehouse or a data lake. You can transform it and move it. You can prepare it for Athena or Redshift to query it, your data set. You can discover cool things, transform, catalog it, and you can design even event-driven ETL pipelines. There's also a cool feature about AWS Glue. There's a notebook studio. It looks like Jupyter Notebook. So if you ever worked with the Jupyter notebook, you can run and monitor, extract, and load ETL jobs. You can visually compose data transformation workflows. You can run even Apache Spark-based serverless jobs, doing schema inspections, and store your data results every step of the job. So yeah, I think we are at the question part.
Yeah, thank you, Anna Maria. It was helpful. I hope that this helped you guys to have a sense how to use services, how to even with this example, I believe you have some glance how to maybe deal this in future. Thank you for that again, Anna Maria, and I hope we help you. Now we are open to some questions that if you have or not have, we are still here. So shoot. We will make sure that this presentation will reach you to everybody, and also this video. So if you need to use something, I believe Miro, we can open for them to use these presentations, even that I think that's helpful if somebody want to use it.
Yeah, of course. They have been added to the ones from the last week also to our YouTube channel, so they're publicly available.
Nice. If there is no questions, then guys, thank you for your attention and good luck on this hackathon, and may the data be with you.
Thank you, guys.
Thank you.
Bye.
Thank you. Bye.
Bye.
Bye, guys.
Thank you. Bye. Bye.